All right, now let's look at this second EKG, and we'll go through it much more quickly. So let's start with rate. And we have 17 beats across the bottom. 17 times 6 is 102. Now there's another way to determine rate that you may have heard of, where you where you find one of the QRSs here that lies upon one of these big lines, and then you go to the next one and you see how many big boxes away it is. If it's one box away, it's 300. If it's two boxes away, it's 150. If it's three boxes away, it's 100, 75, 60, 50, 42, exactly, etc. And so this one, 300, 150, 100, we're a little bit more than 100 because we're on this side, so it gets us up to about the same number. So we have a little bit of a tachycardia at about 102. Now let's see the rhythm. Is there a P for every QRS and a QRS for every P? Let's look at this rhythm strip for 2 because that seems to have a good clear waveform in it. So we will jump down here. I labeled all the P's and all the QRSs with Q's, and there seems to be a 1-to-1 ratio of these things. There's 1 P for every QRS, 1 QRS for every P. The space in between them seems to be about the same, so I would call this a sinus rhythm. And you may remember there's lots of places that a rhythm can originate. It could come from the SA node, it can come from the AV node, it can come from anywhere in the atria and the ventricles. Anything above the ventricles we'll usually call a supraventricular rhythm. And we'll go through some of these as we go through these EKGs. But this one we're going to say is coming from the SA node, so we're calling it a sinus rhythm. So we actually have a sinus tachycardia. Next, let's look at axis. And so we see here F is, I would say it's more positive than it is negative, but it's close. 1 is definitely more positive than negative. So just in case, let's look at 2, and 2 is definitely positive. Let's come here to our little axis diagram, and we said that 1 was positive, F was probably positive, so we're going to be in this area. But let's say that we called F negative, so 1 positive, F negative, we'd be in this area. But if 2 is positive, that means we're on this side of this line here, and so we would still be normal axis. Now let's go down here to V3 and see if we can take a look at the various intervals. The PR looks like it's about 3 boxes, so that would be 120 milliseconds. The QRS, on the other hand, looks like it's also about 3 boxes. So we'll call that one 120 milliseconds. And finally, let's do our QTC corrected. I'll draw a dotted line here in the middle. And I think that our T wave is here. It's on the correct side, so I would say that is also okay. So let's get back up here, and let's say this one we said was 120, that's good. This we said was also 120, that's good. And we said this one was less than 500 milliseconds. So we're golden. So now let's look at our ST segments and our T waves. And we'll look at them geographically again, or anatomically. So we're going to first look at our lateral leads, and I'm going to do something different this time. I'm going to call all of these the lateral leads because they're close enough. I'm going to make a little approximation. Our inferior leads are down here, and then I'm going to call these front ones our anteroseptal ones. Give those a nice little pink color. So now we can look at each of these. So let's first zoom over here to our lateral leads, and so the ST segments look pretty flat here, and the T waves are up in these lateral ones, but let's go to our other lateral ones as well. ST segments look pretty good, and the T waves are up in these, so we're good there. Let's go next to inferior. ST segments look good. T wave up. Oh, here's one that's down. But these are up. So I would call this an isolated T wave inversion in 3, right? It starts having significance when it starts following an anatomic pattern. And that's why we're looking at 2 and F at the same time. If we saw them down here, and here, we say, oh, we have inferior T wave inversions. This little non-specific thing, I don't know what it means, but I'm not too worried about it just yet. Now let's look at our anteroseptal leads, and we see, okay, yeah, we got ST segments look pretty good. T waves are up. This over here may represent a Q wave. A Q wave is an initial downward deflection without an initial. See how there's a little initial upward here, that R? I don't know that I see that here. Maybe if we could zoom in closer, we could see here there's a tiny little R. And then we could say, okay, maybe that's an S. But otherwise, we're going to call that a Q wave. 1 Q wave in V1. Maybe. We're not sure. I don't know if that's real or not. I would Let's take a look at that. And a good thing to do is to look at an old EKG and see if this is old or not. Okay, so our ST segments and our T waves are pretty unremarkable. Now, the real reason I put this particular EKG in here is to look at one thing that is always tested but you almost never see, and it's called the pulmonary disease pattern, or the S1Q3T3, which you're supposed to say is indicative of PE, but it really isn't. You can see it in other things, and you can see PE without it, but it's worth looking at. So first, right here, we see that there is an S in lead 1, hence the S1. Then we look over here to lead 3, and there's a Q, and there is a T-wave inversion in 3. So we have S1Q3T3. And this may be indicative of something called right heart strain, like the heart is trying to pump against a clot in the lungs, and so the right heart is straining, S1Q3T3. So then my final evaluation of this would be that I got a sinus tachycardia with normal intervals, normal ST segments and T waves. Maybe there is this S1Q3T3 pattern, and if my suspicion was high for pulmonary embolus or some sort of pulmonary problem or something that would cause right heart strain, then I would start pursuing that. Otherwise, that's it. Okay, let's go to the next EKG.